let me get you a spin, because a spin's very different because you're not launching yourself out, and it's something that goes for much longer. It's not fractions of a second. It's a spin, can be 30 seconds. It can be a minute, and you'll see most people wind backwards, and they're creating this. It's all about torque in the body, and this is why I realize I'm a terrible skier, because it's the opposite.
So they're winding the spring.
You're winding,
to send
right?
It up. Okay.
And so my hips are going to the left, and my shoulders are going to the right. A lot of abs.
Core work.
Yes. And then you step in, and you ride this outside edge. And then, again, you do the same whip momentum for a jump, except you don't take off, and then you spin. Generally, if I wasn't in heels, I could do more spins. And then once you're there, you'll keep this momentum, and then as I would bring in my arms and my legs, I can just insanely increase the speed of my spin. And likewise, if all of a sudden I wanted to slow it down, I would just open up, and you would see the rotations just kind of almost stop. And so in that way, I was aware of physics. But for figure skaters, we would think about it more in terms of like body awareness of, where your hips are, what torque you need.
Plus, you have to look good doing it.
Yes.
Right, because you're being judged
and what color you look good in.
Right. There are other dimensions of the analysis, of the rank of the scores.
Exactly.
Right.
So you actually, yes, can you tell us what is happening when she does that?
The physics, yeah. So if you... I'd take my shoes off.
I want to see your spin.
Not to say. Wait a minute.
Just
for those of you listening, Neil is taking off his shoes and putting on Sasha's heels.
Cinderella doesn't fit.
All I can tell you is this: Prince Charming is never coming back.
Thank you.
So in physics, here's the deal. So if you set yourself rotating, all right? So I'll do that right now, okay? So here I am rotating, okay? So that's at a speed. Wait, don't applaud yet. You don't know what's about to come, okay? So
you just spun around.
So you can calculate how much angular. So in physics, you might remember from your physics class if you had it or you. So everything that happens in a straight line, you can think of in a rotation. So there's a force. The rotational counterpart is torque. There is mass. The rotational counterpart is moment of inertia. There is, you also have momentum, and the rotational counterpart is just angular momentum. So here's the thing. Once you start rotating, your angular momentum is constant, okay? It's constant. So if I start spinning, and you calculate the angular momentum by, okay, here it is. It is the mass of whatever your body is.
Which in this case would be the biggest figure skater ever.
Here's the point. So your hands have a certain mass, okay, and they're rotating out at this distance. So you have part of your body mass away from your axis of rotation.
Oh.
Okay, so if you can calculate how much angular momentum that is. Now watch. If I bring any part of my body closer to my axis of rotation, then one of the terms in your angular momentum drops. So what happens is the distance to the axis of rotation drops, but your angular momentum stays the same, so something has to increase. Okay? So, because when you multiply these two numbers, you have to get the same answer every time, okay? So if I start changing the distance of the mass of my body to my axis, and I make it smaller, I have to spin up.
Nice.
And so there you have, allow me?
Yes.
Yes, ma'am, okay. So I will spin, and then, okay. And just like she said, because what she needs, right, isn't that right? So you're spinning, you speed up, but then you can stop it by just putting your mass back out. So here's my proposal to you, okay? Here we go. Okay, so put your arms out, okay? So you're my skating physics demo in this moment. So you have a certain amount of mass coming out here. All right? So
wait, for those listening, right now, Sasha has her arms
T-shape.
spread apart.
Spread apart, yes.
And
Okay.
in a T formation. And go ahead.
Exactly. So there's a certain amount of mass along your arm and in your hands. And you also showed earlier when you start a spin, you might start with your leg out. Okay? And then when you bring your leg closer in towards your axis of rotation, you start spinning faster. And okay, so we got this. Oh, I like you have this is an infinity on your wrist. Very cool. Very cool. There's an infinity tattoo.
That is very, yes, that is an infinity tattoo.
Infinity tattoo. Good. Okay. Sorry, I didn't mean that. Okay. So here's my suggestion. I don't know if it's legal. Next time you do this, I think you can do a quint. Is there such a word?
There is such a word.
Good. Quint. 5 turns. Now, how would you do that? I'm going to say you get some lead weight to put in your hand.
Tom Brady all over again. Tom Brady.
Then
Tom Brady of ice skating.
So when you start spinning with lead weights in your hand, even if you're spinning at the same speed that you once were, you have more mass farther away from your rotation axis. So that as you then bring the more mass in, you will spin faster. And I don't know, people will notice if you're grabbing something, holding on to something.
What's going on?
So
Yeah,
maybe
as you skate around, as you skate around the rink with 2 kettlebells in your hand.
It's a little obvious.
So what you do is,
Just
I
get
think
really
you can,
heavy rings.
yeah, that's what I'm saying. No, you
Really
can get
heavy
a
rings.
wrist bracelet and lead infuse the wrist bracelet, and it's just your jewelry.
And meanwhile, I build up huge.
So what I'm saying is, if you did that, the same gestures, you will spin faster. And you'll have to land, you have to figure out the landing. But but once you go...
I'm going to throw this back to you.
What's that?
For spinning, this would absolutely work, and it would give me more torque and momentum when I spin.
Yes.
But I think the extra weight would not allow me to get up as high in the air, and so even if I got extra torque when I pulled in, I would still not be able to rotate as
to
many
think
You
about
need
times.
to work on this. You
So-
need to work
so
on
it's a
this.
trade-off.
Yeah.
Have to think about that.
It's a good thing to think about.
You got to think about that. So this is one of the interesting physics problems where there are 2 variables competing with one another, and you don't know if one is more powerful than the other, or where they meet to get the best combination of both. And that's where you get more interesting, complex problems in physics and in life.